Hi, welcome to Statistics class. This is our lesson, Introduction to Hypothesis Testing. Let's define some terms, or hypothesis testing, or a statistical hypothesis. It is a conjecture about the population parameter, and this conjecture may or may not be true. So a conjecture about the value of a population parameter or a distribution of the population. So hypothesis testing or significance testing is a method for testing a claim or hypothesis about a parameter in a population. So, using data measured in a sample. So, in this method, we test some hypotheses by determining the likelihood that a sample statistics could have been selected if the hypothesis regarding the population parameter were true. So, a logical supposition, an educated guess based on observation. So that is hypothesis testing. And it provides a tentative explanation for certain events, phenomena, or behaviors. And it is a suggested solution for an unexplained occurrence that does not fit into current accepted scientific theory. So this is hypothesis testing or a statistical hypothesis. So for example, the mean midterm score of elementary statistics students is 85 if you want to test the mean, or the distribution score follows a normal distribution. And there are two types of hypotheses. They call it null hypothesis and alternative hypothesis. So null is the statement of conjecture which is being tested, and it is usually denoted as HO, or some are H naught subscript O. So it is a statistical hypothesis that states that there is no difference between a parameter and a specific value, or there is no difference between two parameters, say the mu or the mean or the variance. So that is the null hypothesis. So just think about it. There is no difference. So that is your null hypothesis. And then an alternative hypothesis, it is a statement that will be accepted in the event that the null hypothesis is rejected. So it is usually denoted as HA, or for some textbook they are using H1. So it is a statistical hypothesis that states the existence of a difference between a parameter and a specific value, or states that there is a difference between two parameters. So just remember, if I say null hypothesis, there is no difference. And if I say alternative hypothesis, just remember that there is a difference. Okay, so let's proceed to some reminders. The null hypothesis is generally a statement of equality or status quo, or will imply no change. So from the word itself, null. And then the hypotheses are statements about a parameter or distribution of the population. So the null and alternative hypotheses are mutually exclusive. So I believe you understand what is mutually exclusive. So let's have some example in stating the null and alternative hypothesis. For example, in a study, is there a significant difference in the academic performance of agriculture and education students? So when you state it in a null hypothesis, you can say there is no significant difference in the academic performance of agriculture and education students. And for your alternative hypothesis, you can state there is a significant difference in the academic performance of agriculture and education students. So another example, in a question, Is there a significant relationship between the attitude score and academic performance of student athletes? So, if you want to state your null hypothesis, it can be this way. There is no significant relationship between the attitude score and academic performance of student athletes. And for your alternative hypothesis or HA or H1, there is a significant relationship between the attitude score and academic performance of student athletes. Now, what is the test of statistical hypothesis? If there is statistical hypothesis, then we have to test it. So it is a procedure or a rule for deciding whether to reject HO based on a sample drawn from the population. So example, reject HO if X bar or sample mean is greater than 80. Otherwise, we fail to reject HO. So what are the courses of action? So in a test of a hypothesis, we need to have an action because we are testing. We can either reject HO or fail to reject HO or accept HO. For in elementary term, but the right term actually is fail to reject HO or accept HO. So in consequence, a correct decision is made when reject a false hypothesis. Since it is false, so we have to reject, then you made a correct decision. Or fail to reject a true hypothesis, or you accept the true hypothesis, then you made a correct decision. On the other hand, we commit an error in making a decision when we reject a true hypothesis or fail to reject a false hypothesis. So we know that in this life or in the testing, there is no such thing as 100% sure. So we reject a true hypothesis or fail to reject a false hypothesis, then we commit an error. What are these two types of error? So the first type of error committed is the type 1 error. So when I say a type 1 error, it is committed when we reject a true null hypothesis. Supposed to be the null hypothesis that there is no difference. It is true in reality, but in our test, we reject it. So you've committed a type 1 error. So also it is committed when the null hypothesis HO is rejected where it is the true solution to the problem. And a type 1 error occurs if you reject the null hypothesis when it is true. So remember, type 1 error, you reject a true null hypothesis. And then the second one or the second type of error is the type 2 error. So it is committed when we accept a false null hypothesis and is committed when the alternative hypothesis is rejected where it is the true solution to the problem. And a type 2 error occurs if you do not reject the null hypothesis when it is false. Your test resulted that there is no significant difference when actually there is. So you've committed a type 2 error. So to show you in a matrix form, this is a decision matrix. So this is your action. So in reality, example HO or your null hypothesis that there is no significant difference, it is true. But your action, you reject it when actually it is true, then you committed a type 1 error. And if HO is false and you really reject it, then you have made a correct decision in your hypothesis testing. And if your action, you fail to reject HO, when HO is actually true, then you made a correct decision because you have accepted the HO or the null hypothesis. However, or on the other hand, if your action, you fail to reject HO or you accept the null hypothesis, when null hypothesis is actually false, then you committed a type 2 error. So let's show you some example. So for example, in this illustration, this is a type 1 error or false positive. Example, the null hypothesis is he is not pregnant, and your alternative hypothesis is he is pregnant. But when you test it, you say you're pregnant, then you reject HO when it is true. So supposed to be he is not pregnant, but you said that he is pregnant. And also, for type 2 error or false negative, you've declared that you are not pregnant. So your null hypothesis is she is not pregnant. And your alternative is she is pregnant. So what you did is you accept HO. So this one, she is not pregnant. You accept it when actually it is false. So you've committed a type 2 error. So again, for type 1 error that is false positive, you reject HO when it is true. Because your HO should be he is not pregnant, but you reject it. Now let's proceed to the probability of committing errors. We have the probability of a type 2 error and the probability of type 1 error. So type 2 error, so all our hypothesis testing is governed by probability as well. So it is usually denoted by beta. And it is equal to the probability of type 2 error is the probability that you accept HO when HO is false. And the probability of a type 1 error is usually denoted by alpha. So alpha is equal to the probability of committing a type 1 error. And that is the probability of rejecting HO or accepting the alternative hypothesis when actually your null hypothesis is true or your HO is true. So it is also known as the level of significance of a statistical test. What is this level of significance? So the level of significance is the maximum probability of committing a type 1 error. And this probability is symbolized by a Greek letter alpha. That is, the probability of type 1 error is equal to alpha. So level of significance or significance level refers to a criterion of judgment upon which a decision is made regarding the value stated in a null hypothesis. The criterion is based on the probability of obtaining a statistic measured in a sample if the value stated in the null hypothesis were true. So in behavioral science, the criterion or level of significance is typically set at 5%. When the probability of obtaining a sample mean is less than 5% if the null hypothesis were true, then we reject the value stated in the null hypothesis. So usually the common or the default level of significance is 5% and 1%. So here this one. So the significance level again is the criterion used for rejecting the null hypothesis. The choice of levels is largely subjective and the most common choices for the level of significance are alpha is equal to 0.05 and 0.01 or 5% and 1%. So setting alpha at 5% or 0.05 indicates that the researcher is 95% confident that the alternative hypothesis is true or accepted, and the researcher has 5% chance of rejecting the null hypothesis. So that is your probability of committing a type 1 error. So reducing the alpha at 0.01 indicates that the researcher is 99% confident that he is making the right decision and 1% chance of committing error. So that's the purpose of level of significance. So reminders that the sum of alpha and beta is not equal to 1. That is, they are not complementary events. We wish to minimize both alpha and beta for you to maximize your statistical power. And we set alpha at a very small value, usually 0.01, 0.05, or some, and rarely they are using 0.10. So the tests developed in statistical theory are constructed in such a way that both alpha and beta are minimized. So what is this critical region or rejection and acceptance region? So in your hypothesis testing, you should have your region where you would accept your hypothesis or reject it. So you need to have this rejection and acceptance region. So the rejection region is the region in which the null hypothesis HO is rejected if the test statistics falls within it. By setting the level of significance, the rejection or critical value can be determined. It serves as the basis whether the hypothesis is rejected or not rejected. So remember, again, rejection region is the basis whether the hypothesis is rejected or not rejected. And the location of the rejection region is determined by the nature of the alternative hypothesis, whether the hypothesis is one-tailed or a two-tailed test. So the critical value separates the critical region from the non-critical region. The symbol, sometimes the symbol is CV. So the critical or rejection region is the range of values of the test value that indicates that there is a significant difference and that the null hypothesis should be rejected. So it can be uh, projected here or stated here in your critical region. So the non-critical or non-rejection region is the range of values of the test value that indicates that the difference was probably due to chance and that the null hypothesis should not be rejected. So that is your rejection and the acceptance region. So we have these steps to hypothesis testing. So throughout this module or lessons, we will use these basic steps to hypothesis testing. And step 1 is you have to state the hypothesis, your null and alternative hypothesis. We begin by stating the value of a population mean in a null hypothesis which we presume is true. And then step 2, we set the criteria for a decision or alpha, let's say 5% or 1%. So to set the criteria for a decision, we state the level of significance for a test. And then step 3, we compute the test statistics, so whatever statistical tool we will use. So you have to compute it and show the necessary result and use the appropriate test procedure and give the necessary analysis result. And then step 4, you have to set critical region and make a decision. So state your decision rule. We use the value of the test statistic to decide on the null hypothesis. The decision is based on the probability of obtaining a sample mean given that the value stated in the null hypothesis is true. And then step 5 is our conclusion and recommendation. So you have to state your conclusion and recommendation based on the result. So before we end, I would like to leave this text. God has tasked for this age, and they are to stand out plain and unmistakable. So the question is, are we significantly different from this world or there are no differences? So for our next topic, hypothesis testing on one population, specifically the Z test. So God bless you and have a nice day.